So let's say I gave you this function. F of x is equal to 8x to the fifth minus 7x to the fourth plus 6x squared plus 3x minus 1. And I wanted to find the zeros of this, meaning I want to find the x-intercepts. Well, this is very long and very complicated, and there are no, we don't have any tools to implement to be able to find the zeros of this. We can't use AC method because that's for quadratics. We can't use factor by grouping. There's too many terms here, and none of the groups have really anything in common that would be worth sharing. So we have to have a way to be able to factor this and to be able to find the zeros of it. And so this is where what we're about to get into called synthetic division. Synthetic division. Basically, it boils down to it lets us factor something like this. It lets us factor that, or something like that. Lets us find the zeros. So how I want to start is I want you to just put your pencil down, just watch what I'm doing, and all I'm going to do is show you the steps and how, and just set up a problem. And then after I do this example, then we'll get into a full example and I'll show you how everything's set up. So let's say, so it starts out with the box and then we have a line like this. Just watch me for right now. So this is how it starts, and then you're going to have a number in this box. Let's call it 3. So that's the number in the box. And then you're going to have several numbers lined up here, and give yourself just a little space. So let's say 1, 4, -5, and 5. All right? So if you want to go ahead and write that part down, go ahead. That's just a setup. And so when you're done with that, put your pencil down and just follow along with me, and I'll tell you when to pick it back up. So there's a repetitive process here that we're just going to do over and over. And the way it works is you take this first number and you bring it to the bottom. You just draw an arrow and it goes straight to the bottom. All right? Now you take this number and you multiply it by what's in the box. 1 times 3 is 3. And then you always add down. Add down, that gives you 7. And now the process repeats. You need to start writing now if you haven't started already. So when you have a number down here, you take it and multiply it by the box. 7 times 3 is 21. That goes here. And you always add down. See if you can finish the last 2 out. So when you add down here, you get 16. Then when you have a number down there below the line, you multiply it to what's in the box. 16 times 3 is 48. Always add down gives you 53. All right, so that's the setup, and that's the process of how to do it. Now I'm going to start by working an example, and I'll show you where all these numbers come from, because you'll have to populate those. Example 1. And this is how you'll see it written. You'll see it divide x cubed plus 4x squared minus 5x plus 5 by x minus 3 using synthetic divisions. All right, I'll get into what all this is doing and what it's saying. So you have the setup here, and you always start with the same setup. You have the box, and then you're going to have your line. All right, so let's ignore the box for a second. We'll get to that. What numbers go here? So these numbers that go on this line are the coefficients of whatever you're given here. So this is 1, 4, -5, and 5. So it just goes in order. 1, 4, -5, and 5. So that goes here. Now we're dealing with the box, and when we deal with the box, we have to use what we're dividing by here, this x minus 3. So we don't put the x minus 3 in there. What we do is we set this equal to 0, solve for x, and that's what we plug into the box. X minus 3 is equal to 0, so x is equal to 3. That's what we plug into the box. 3. All right, pause the video and try to work this yourself. So it starts by bringing the 1 down. And then 1 times 3 is 3. That goes there. Always add down. That gives you 7. 7 times 3 is 21. Always add down. 16. 16 times 3 is 48. Always add down. Gives you 53. So this is the same problem as before. Now I just added in where all these numbers come from. So now we're going to add on a little bit more. Now we need to determine what these numbers down here represent. All of these numbers below the equal sign. So let's do that now. And always start on the far right. Always start with this number here. Because if you do that, we start with the furthest number on the right, and we're going to work our way back to the left. And everything's going to work in sequential order this way. So this number is always your remainder, your R, the remainder. That's what's left over. We divided these two things, and this is what's left over. That means they didn't divide evenly. And so what that means in simple terms is, say we did 4 divided by 2, the answer is 2. There's nothing with nothing left over. But if we did 5 divided by 2, that gets us 2.5. So we got the 2 and we had 0.5 left over. That's basically what this is saying. We had 53 divided by x minus 3 left over. All right. So that's our remainder. This is our constant. This is our x to the first power, x to the second power, and there would be, if there's another number, it'd be x to the third and x to the fourth. So start with the far right, that's your remainder, constant, x, and x squared. And the way we write this now is these numbers are our coefficients to these variables. So that means the coefficient of x squared term is 1. So we get x squared plus 7x plus 16. All right, following so far? All right, and then we have to deal with that 53 on the end over there. And what's happening is we have a plus. Now watch, be careful here. We're going to have a division sign, because remember, this is the remainder. So it's 53 on the top, that's what we're left with, and then it's whatever we divided this whole thing by, which was x minus 3. So it's similar to the 4 over 2 and 5 divided by 2 example I showed you, but there's how the setup would go. Let's try one more. We're going to try several more, actually. Give this one a try. Example 2. Divide 5x cubed plus 6x plus 8 by x plus 2 using synthetic division. All right. So what I want you to do is all I want you to do here is to do the setup. Do your box and write your numbers with the line. Don't go any further than that. Pause it. When you get there, then unpause it and watch me. Okay. So we know we're going to have our setup, a box and a line. And what goes in the box? Well, we have to come over here and set this thing equal to 0. So that is x equals -2. So -2 goes in the box. Now we have to populate all these numbers, which are coefficients of this thing. So what I have to be careful with here, I can't just go blindly and start throwing all these numbers in and then working through the process. Because there's a little bit of a trick in this one. Notice that you don't have an x squared. There's only an x cubed and an x and then a constant. So when you have something missing like this, you have to make sure to account for it. You have to add it back in there. So I can rewrite it as 5x cubed, and I need to add a 0, and I need to add a 0x squared in here. So 0 times x squared. I can do that because 0 times anything is just 0, and I'm not changing the function here. Plus 6x plus 8. So you have to make sure to account for that. What I have is 5, 0, 6, and 8. Now pause it and give it a whirl. Do just like we did previous example. So we start bringing down the first one, which is 5. 5 times -2 is -10. Always add down, which is -10. -10 times -2 is a positive 20, and always add down. 26. 26 times -2, -52. Always add down. And then we're almost there. That's -44. And so now it's just writing our equation out here. So go ahead and try to do that yourself and look at the previous example. Start on the far right and work your way back to the left. This is R. This is my constant. This is my x. This is my x squared. X cubed, x to the 4th, x to the 5th, and so on. I stop here because that's where my number stops. All right? So now these are my coefficients to these terms. So 5x squared minus 10x plus 26. And then this is minus, remember this is your remainder. You have 44 left over that you still need to divide by that x plus 2. All right, next we're going to get into what this remainder is actually doing. More specifically, What is it doing when the remainder is 0? That's what we want to look at. What happens when the remainder is 0, and what does that mean for us? All right, that's what we're going to do next.